So hello everyone. Welcome to our another Build Prep webinar. My name is Adinda. I'm Customer Success Manager at AMIS. We want to thank everybody for joining us today. We noticed there's a mix of MJF and SLS users in the audience, as well as print service bureaus. So we think that might make up for an interesting discussion at the end. Today, my colleague Chris will talk a little bit more about nesting strategy and introduce our new AMIS Runtime. Before he does so, we'll have a quick mention that there will be a Q&A at the end of the session. So if you have any questions, feel free to drop them in the chat. And we'll also share the presentation afterwards with you. With that said, I'll hand things over to Chris.
Right. Thanks a lot, Adinda. And thanks everybody for joining us today, indeed, for another session of the Better Build Prep webinar. And this time we've chosen for a bit of a different approach. We are, in fact, going to look really at the strategy more, because as we talk to more and more users, we really notice that it's about approach. It's about how do you approach your nesting, and that's not something that should be statical in a sense. And we quite often compare it to a chef and his kitchen. It's like all of you busy with build preparation. You're a chef in your kitchen, and one day they will ask you to make something Italian, and the next day they ask you to make something I don't know, Spanish or Japanese or whatever. And AMIS Pro in that sense is just a tool. It's your kitchen. And you need to find, of course, the tools inside the kitchen in order to be able to prepare for the best dish. And that, for each type of restaurant, let's say, requires a bit of a different strategy. So that's why we come back on that quite specifically. And that's why today we really want to have, a few of these possible strategies that we want to share with you. I say a few because basically there is not like 5 or 7 strategies. It's just that learning by doing, you will see that there are other ways to approach the same batch, or other ways to approach a similar batch with different requirements. So it's of course about mixing the right ingredients and come to the best dish for that day, for that batch, let's say. Now, secondly, what I also want to zoom into is the AMIS Runtime, the headless engine for AMIS Pro, which basically allows you not only to, well, let's say, build your own strategies, but also to translate all your IP, all your intellectual property, because I believe there's a lot of potential intellectual property in your nesting. You can translate that into scripts, which you can use, basically for all your nesting, and that's where the added value lies. But of course, I will zoom into that at a later point. So I kind of introduced a bit already. Why does it matter? Of course, because it's in the end all about TCO. It's about CPP. It's about making your business flourish. And if you're going to make for each time, let's say your competition has McDonald's, and you're every time making the food for a 2-star Michelin star restaurant, that might not be the best approach. So you might have to choose sometimes really for cost per part. But on the other hand, it's quite possible that if one part needs to be very accurate and needs to be very within certain limits, then of course you're not going to get there with your McDonald's dish for that day. So in that case, you need to have another approach, and you need to go for it in a different way. So as said, I will zoom into 3 possible approaches. Density first, maybe a bit of McDonald's, but of course it still has to be decent and good and safe, and it needs to be in order. Stability first, that's just a name, that's just how we called it. It's about placing certain parts safe, because those parts might make or break your batch, or they might make or break the return on investment on that specific batch. And then of course there are other cases, and I've had a couple of examples lately, I think he's here today also about dental applications, whereby, of course, accuracy was important, which led to very interesting ways of nesting. Some, yeah, I will share some ideas later, but unfortunately, most of the batches that our users send us are not. Well, we can't share them, of course, in public, which we fully understand. So let's go into the density first strategy, and it's one that we see quite a lot, and basically I can imagine you also see them quite a lot passing. It's these medium and small parts, not too big parts that influence the heat too much, or the binder too much. um, it's about nesting density, where your potential return on investment lies the most. And there, of course, with fast iteration, you will go through quickly to come to a result which will, for those expectations, give you the best result. Now, perhaps there's something else that I should still mention. Of course, I'm going already on a deep dive. For some of you, some of these ideas might be quite new, and also when I demo this, you might notice like, oh, I don't know this yet, or I haven't seen this yet. Don't worry, it's just really into the strategies, the how to. I will be very glad to explain to you in a one-on-one session where we go through your well, really getting started with AMIS Pro, of course. So this is immediately a bit of a deep dive to just get the concepts right, the idea of the strategy, the kitchen, to guide you through. So for this density first demo, I think you understand what it is about. I will just share my other screen with this SLS printer. Some of you might actually recognize it as an EOSP396. It's actually there, so I shouldn't hide it. And so you got quite a bit of parts with not too many requirements. They're relatively medium, small, bit of mix there, and we're focusing on price. So let's do that in the first place. Now, I'm having quite a low gap distance. I'm having quite a low wall margin. It's of course up to you to choose, and we know very well that every chef, everyone amongst you, has its own recipes and its own ways of nesting things and of rotating and preparing things. I'll just give it a quick nest just to have an idea of where we will end up. And I quite often do that, even though it's not really necessary, because just as well you could start, of course, start with your part preparation, which is in a sense more logical. Now, the first part is my no build zone. That, of course, I don't want to touch. It's a locked part in there. And then I have this nice little dragging standing here as a next one. Okay, so the idea is going quick, not only just to save a bit of time on the person who is actually doing this job, because that's also a cost, but also just like, okay, let's the quality is a requirement, of course, it needs to be good, but we shouldn't waste more time on it than necessary. I'll just use Alt N to go through my parts quickly, and if I want to return, it's Alt P for Alt Previous, as is indicated here on the buttons. But I use quite a bit of the shortcuts. Okay, this one looks okay. Rotation looks okay. Next one, this one is quite the same, but a bit bigger. Okay, this one is not perfect. Let's rotate it. I can rotate it freely, or I can use my Alt button to immediately give it a pre-configured rotation. So let's put it up in that way. It's not too bulky, so I shouldn't change anything else to that. This one is okay. This one is okay. Although perhaps I can maybe choose to rotate a bit like this. This one also I will put up a bit just for having more possibilities on the density. Next part looks okay. The open part up is in line with the specifications by HP and most SLS machines anyway. Okay, and then I've got this insole, which I probably won't be printing flat. Some of you may notice that the rotation actually changed. Nowadays, this one actually changes together with the rotation. You can still revert to the old system if you prefer that, but for many people have requested us to put this in as a standard. By the way, you also have the reset button now, which makes also your life easy if you made a mistake and just want to restart it, so to say. And of course, I love taking a bit of a risk because I say now you have, but basically this is in the next update. So I'm already running this in let's say a beta version, but it's already quite well tested. So don't worry. Um, okay. Oh, I've got a lot of installs here. So instead of just selecting one and doing it one by one, I'm going to do it a little bit different, of course. And I'm just going to select all these parts by using my shift button. I select them all at the same time. And I'm going to rotate them from inside here. Um, that's just actually very easy. Also with shortcut buttons, Alt X, Y, Z. So I'll just give them a rotation like this and back again like this. Oh no, hang on. I changed my language again of my keyboard, which is never a good plan because then the rotation goes wrong. Of course. And there we are. 6 clicks because I put it at 15 degrees. To rotate with each click, but you can also just hold and it will rotate. Good. So let's get through further. With the next part, I will just click on it. Oh, okay. Here we also want to make the rotation a bit better. Next part, this one we probably want to rotate this part up, and here with the holes all a bit in the same direction. Makes sense. This one I will also rotate in the same direction as the other one. And then give it a lift up so that it doesn't influence too much the density on a specific layer, which is of course also something you might want to avoid in many cases. This one also with the holes probably up in order to maintain the quality, and then putting that one, oh, I didn't get it, putting that one slightly up in the right direction. Next, this one also, I think I want to put it upright for better printing. And there I didn't use my Alt button. This one looks fine, and this one also looks fine, 500 parts. Now, let's just give it the renest. I quite often do that just to see where we get and what we actually have here. And then yeah, let's continue from here. What we might still do is maybe combining these 500 parts. And 500 parts, who will be busy finding them out? And they might get damaged, so why not give them a nice cage? Now, 500 in one cage, that's going to be quite a huge cage. So I suggest we actually just duplicate the part. I just duplicate it now 5 times. There we go. And I give it 100 each. Oh, that's 10. Next is 100. Next is 100. Next is 100. Oh, there we go. And the last one, also 100. And then just cage them one by one, which is basically a nesting operation. I will just take the normal cuboid without text. You can add text now to the box, and just cage them all like that, and perhaps put them again askew a bit as well. I won't do all 5 for now, but that's the basic idea. So you saw also in just 2 seconds you have them batched or you have them boxed. So that goes pretty fast. Now, with this approach, so we went through the parts very quickly, just giving them some basic rotation that it's like acceptable, let's say. But we're having a nesting density of 15%, which as such for many of you would be acceptable. I think they would say like, okay, let's anyway go for it. But with some peaks up to 23%. So you might still want to reduce that max layer density so that it doesn't reach 23%, but we're weighing quality over price here. So let's give it a max layer density so that each layer is restricted in density of, let's say, 20%, just to get off the highest peaks, but still keep it in a very high density, so a very high return on investment for this batch. And that's basically then how we have our first strategy, our first batch with then indeed the peaks only up to 20.71%. but reasonable and good to go for this kind of nesting operation. Good. That's the first, and I already noticed that I'm talking too much. That's always the mistake. So I will need to keep some time also available for the runtime today. Now, but let's anyway skip immediately to the next possible strategy, the stability first strategy, and that's typically a case whereby you have these tall parts, dominant parts who will influence a lot the heat inside your batch, who will influence a lot the parts around it potentially. So there you have to be careful quite often because also a big bulky part or a big flat part means it's quite an expensive part. So you don't want it to fail. So you will look at that in a specific way. Okay, so here we've got this big part, and you already noticed that if I rotate it by using Z rotation, it jumps with a certain angle, and I now put it at 22 degrees, if I remember correctly. Of course, in that way, I can't really get it inside because it's either too long or too wide to fit in. Oh yeah, and I also want to show that you can just keep on rotating by clicking that continuously. So let's go to our settings in the configuration and just give a part manipulation of 1 degree at a time. Now, since you can just hold it, it means you can just very quickly shift up to the moment that you have the right position. And actually, given its rotation, I will also still rotate it a little bit upwards like that. And then it should fit inside our batch. No, it doesn't because I did something wrong, I think. Yeah. Oh, by the way, the I you did notice perhaps also that in this case, the gap distance and wall margin have changed a bit, although you can, yeah, still set the margin perhaps a bit higher for this case. Good. So there we have our part, and it's located quite in the middle, but it's not exactly yet where we want it. There's one difference that I still want to show you in this case. If I don't use my max layer density, my parts will first be nested from the 0, 0, 0 point here in the corner, in our case, of the batch. But actually, for a part that we want to be in the middle, because it's huge and it's taking lots of space, we would want it to be a bit more in the middle immediately. And for that, you can use the max layer density, because that's an algorithm that will basically start putting the parts from the middle onwards. So if I nest now, and if you watch carefully, you will see that it shifted just a millimeter over there. Now, still not perfect, we would think, because basically it's down below, and for such parts, you might actually want to put it up a little. I can do that, of course, using this arrow, or alternatively, I just go stand here in the correct positioning part, and I just use the up the arrows to move it upwards. So that's a very easy way, and of course, it also works in the other ones. Just using tab, you can go up and down, of course, through the different positions. By the way, if I just go down here below 0, you will see that the part actually just flips outside. So it's also a means to remove your parts from within the from within the build box. If you need to remove a single part, you can do it using that function. Okay, I placed it back in the middle because, of course, I now, meanwhile, ruined it. I'm going to put it up again. Then I'm going to lock it in position so that basically from now onwards, I know this part is in a place where I want it to be, where it's got a, oh no, actually, I do want to shift it a little more. Voila, further from the side. If you go too far, by the way, you will see that I can't lock its position anymore. So then you know that you actually went too far. So I'm just going to go down again up to the moment when it's again possible to lock its position. After that, I can add multiple other parts which may or may not be so crucial or so needs. Oh no, I don't need to do that. I need to use Control to select multiple parts, of course. and continue my nesting from there, adding multiple parts, adding multiple hundreds. Some of you might think that it's like oh no, that it's difficult to then find back your big part in the middle, so that it becomes a difficulty to actually still position it. But you can just as well load all the parts together, and then in the output use the preview. Just grab your part from there, and you can shift up and down until you find your part. You can just select it from there, and then again start working on it, locking it position, so that it's actually not too difficult in that sense. Good. That's the next strategy, the stability first. Third one is about accuracy. In that one, of course, you will get it. This is the sushi chef here, right? Everything needs to be perfectly in order, perfectly aligned, and there is no part that allows for a minor mistake or quality issue or whatever. You should not allow for it. Um, and that, of course, will require a bit more work. It's quite logical, but you can also just use a different approach really there. And first of all, what I would do, and you see that I'm using the exact same nest as before, except that I added a couple of let's say more difficult parts. First of all, you will look at your generic gap distances and wall margins. So your gap distances might be up a bit higher, and you will quite often immediately start with putting your max layer density quite a bit down, which indeed will allow you to, well, have better quality of your parts. That's on the nesting side. Of course, on the part prep side, you will also start looking at what's going to bother my nesting. And if you look at a part like this with a flat wall, definitely if it comes against the side of your batch, that's going to have an influence. So you need to do something about that. So let's be smart about this and put this one back at 15 degrees with any switch. There we are. So now I'm back at 15 degrees at a time, so I can easily position it 45, 45 in each direction. There we are. That will have less of an impact on the side. However, you could also choose, and it really depends a bit on the case, on the parts themselves, to just increase the nesting gap. Meaning you leave it in position as it is, but you significantly increase the nesting gap so the heat input doesn't influence, or the potential bleeding is not going through by increasing seriously this nesting gap here. And I already put it at 10 millimeters for this one, so you can do that on a part specific basis. Also in that sense, and that might actually still be useful for your density approach, and when you really want to achieve a high density and your quality is not that important, you might actually give more allowed rotations to more parts, meaning they can fit inside in any rotation you can think of, thereby finding its best position to have the lowest cost per part, of course, to have the highest density inside your batch, so that you may consider for the density, for the high density approach. Now, for this accuracy approach, you will pay even more attention, of course, about the positioning of your parts and the rotation of your parts. So you would again put this one up straight. You would take more care of adding, where necessary, the boxes to prevent your parts from breaking afterwards. You would take more care about if possible and if allowed by the customer, you would consider, of course, shelling your parts. Create a shell, maybe adding a lattice structure. It only takes also a few seconds to do that. And maybe it's a bit slower when I'm running at the same time a presentation and having my Zoom open, of course. But you see that it does take only a few seconds to do so. So now I have a section part here, which of course will influence the density, which will of course allow for a better quality nesting if allowed by your customer. So important here, I think, is that yes, he will pay more attention to your parts and how to position them, how to keep distance from other parts. Maybe foreseeing more boxes around them, more shell parts, lattices inside, etc. But even more importantly, on your nesting settings, you will actually, of course, allow for less density, reduce the maximum density, and then you will see if I now show the density here calculated. Yes, we're staying nicely below this 13%. Here you see tremendous gaps, which I caused myself because I didn't yet rotate the parts as we should have done that. Obviously, less parts will fit inside your build box. That's just how it is, of course, if you're looking at accuracy first. But so let's assume that I made a better job here in preparing my parts, of course. Reducing your layer density, maybe allowing z-axis rotation, but of course you wouldn't allow for all rotations. And yeah, maybe in some cases for some specific parts, but not for all parts, because that's why you did all the work on preparing the rotation of the parts, of course. And that is more how you would approach this more high quality batch, if of course you have a little more time to rotate the parts in the appropriate position. Now, no, let's discard that one. Important, it's really about each part and every part. Note, of course, also that you can rotate several parts at the same time, so you go much faster in that way, of course. Also know that you can duplicate parts, which allows you to give a different rotation to different parts or to the copy of the same part, which might be important to just fit in a little more, because as we saw with the drone wing that I was showing before, it didn't fit many wings inside, of course, but you might just fit a second one in, on the condition that you make a copy, which you maybe slightly rotate differently or just in the opposite way, so that you anyway have the same quality, but just a little more parts, which is still part of the goal, which still allows you, of course, to lower your cost per part. But with the accuracy approach, we're looking at fewer remakes, we're looking at higher quality. So by in that way, lowering your total cost of ownership of your machine. Now, you're seeing me here in AMIS Pro doing a lot of rotating of parts, putting parts in position, which is, of course, still needed. And we're still, by the way, we'll get to that, applying more and more steps to make that even easier for you. And for example, the positioning of the parts. So, and that's very useful, and very interesting. But imagine that you can just make scripts out of that. That you can just say like, okay, I notice here that I've got a flat part, and it's quite big. So handle with care. It needs to be a bit in the middle. It needs to be a bit up in the batch, not totally down. And then the next one, a very bulky part. Maybe I'm gonna hollow it, maybe not, if allowed. But anyway, I need to keep more distance on the sides of that part. So imagine you could translate your intellectual property, because that's what it is. It's your knowledge on what is the best nesting for your machine. And it's basically also something that you can make a difference in comparison with your competitor. If you nest better, if your IP is in there, then that allows you, of course, again, to have a lower cost per part. Now, imagine you can run that headless and without having the difficulty and having it calculated automatically. And that's how we come to runtime. Meaning, in runtime, so runtime is indeed the headless engine of AMIS Pro. It allows you to basically write scripts that tell AMIS Pro or AMIS software in general, the API, what to do with all the parts that are in a certain inbox, that are in a certain part. And the first question I would probably get on this one, so I'll prevent it by this. is of course like, oh, but then I need to be able to script. I need people that are actually able to script. Now, don't worry too much because I have never written one line, one single line of code in my entire life. And the demo that I'm going to show you in just a couple of minutes was actually made by me. Hooray, thank you. Of course, with a lot of help from AI, but just to demonstrate that it is possible to go quite far, even if you're not that knowledgeable or if you don't have the in-house capacity to do scripting. Anyway, I would strongly suggest to start easy. Basically, with the idea, I'm going to get my part somewhere, and that changes continuously, of course. But I'm going to get my part somewhere. I'm going to apply certain nesting to it, a certain generic, let's say, generic approach to nest with a bit of careful density, a bit of careful rotation of parts. And then I'm just going to have an operator view, have a look at it, and somebody with the IP, with the knowledge, and he's or she's going to see like, no, no, I don't like this part there. It's too close to the wall, or that one is too close to that one. So he can do changes, renest again, and anyway, send it to the printer. The big advantage here already is that you can run it continuously. If you have, for example, nestings for a whole week to make, or for 5, 6 nestings for the next day, as soon as a new order comes in, you can just have everything recalculated immediately, automatically. And that's already, I think that's the biggest gain that you can have from that. Is just that all this groundwork doesn't need to be redone. You don't need to re-nest 6 batches because a new order from some customer came in. Risking also to ruin some of the batches that you already previously made. So that's the potential gain. And then later on, of course, you can start thinking about building your own workflow, your own strategy, translating, as I said, your IP into a certain workflow. And that at this moment is already possible. And actually, oh, sorry, that was too quick. It's already being done at one of our customers in the UK. Not exactly this workflow because they have their own, of course, but it's really about, okay, go get my part somewhere. Now, first I'm going to analyze my part. This one is a big one. This one is a flat one. This one is etc., etc. Let's pre-rotate them in a certain position so that their build box is the bounding box is as small as possible. And from there, let's rotate it in a certain position. We've identified the specific parts, the bulky parts, the thin parts, etc. So we can use that information to basically assign certain rules to those parts, of course. We can also make choices at that point, like, okay, that one we're going to print with HP. Then in that case, let's keep in mind X, Y, and Z. And that one will be on the SLS. So let's keep in mind there is a no build zone, and let's keep etc., etc. So I'm not going to go through every step because it's going to take us too long. But I guess you understand the possibility to translate your IP into a workflow, which basically allows you to run day and night, and a new order comes in and everything is redone. As long as you don't press print or don't put a certain batch in print, every batch that is in wait can basically be optimized continuously. And when optimizing, I'll get to that. I'll get to that in just a second. So I think I mentioned most of this, that you actually can gain quite a bit of it. And we calculated, you don't have to trust me because you can try it for yourself, of course, with just even 2 to 4 batches a week, you can already profit from AMIS Runtime. And that's basically just because you don't lose so much time on your build preparation, but also, of course, because if you have multiple batches to fill, your parts will be ideally stretched out, or you can write scripts to ideally stretch out your parts or divide your parts over the different builds. So just to avoid that all the big parts are in one build and all the small ones are in another, etc., etc. You can make perfect combinations there, and there's potentially a lot of gain. So let's now move to the most boring demo you've ever seen. Boring because there is basically not a lot to see because it's, in this case, running from my command. If I find it anyway, that is right. Too many screens here that I've got open. So there we are. Okay. Right. And then this one. I'm struggling a bit here because I've got too many screens. Apologies for that. Um, let's move that upwards so you also get to see something. There. Okay. These are a number of scripts that I've made in preparation of, well, not only this session, but a couple of other sessions as well. So let's first tell my computer that I need to go to that place to start running one of those scripts. The one I've made was basically an idea saying, and I will already start running it, by the way, saying like, okay, here you find a lot of parts that need to be nested. Here you find details on the parts, how many quantity, what quantity do I need of these parts. So start calculating me some batches for that. And not just nesting it as such, but and here we'll see start appearing the that's from a previous demo, appearing the results. I want you to check the size of the parts, and I want you to categorize the parts into different sizes: small, medium, large. And then of course first divide all the large parts over the different builds, and then start filling up with the smaller ones, so to say. But first of all, of course, that's the classify order, which is now running, by the way. But of course, I need to know how many batches I will actually need to, well, pump in all these parts. So it's going to calculate given to a certain quantity that I actually gave it. Like, okay, my assumed maximum density is 12% for these batches. So just assume that you have 12% for the volume of each. So see how many batches you will need to actually store that in. I believe it's 7 batches that it will create. And so basically, after dividing all the parts, it will start creating or nesting really the batches as I instructed it to nest that. By the way, you can, of course, foresee for yourself, just to make your life easier, a configuration file. No, where do I? Yeah, there you are. In which you can easily switch your preferences for your nesting. For example, here I said like, okay, you can stop looking for solutions after 2 iterations. In reality, you might want to make that a bit longer, of course. You can have a target density of 12% in my case, but maybe you have a higher intention, or maybe you already think further and you think like, oh, but if I have a lot of small parts, I want a higher density. And so that would be a good sign, of course, if you start thinking like that. Now I'm going back to my outbox, and there's the first nesting is done already. And that's the demo. I know, quite boring, right? But you will see, and I'm sure most of you actually do see, what possibilities you got here to actually store your IP into real batches, into real life. Still, you will need this one person having a final look at it. Definitely in the beginning, when you start building the scripts, you will need to look at it. But that really allows you to optimize your nestings over different batches and continuously. A last minute order comes in, doesn't matter. We just rebatch everything again from scratch, and we have a solution there. Right. As for AMIS Runtime, and now I again have to see that I share the right screen, of course. Right, this should be it. It's all there, meaning we have the full documentation available. We have a couple of examples which are just available in the package that we can send you. The API is there, of course, and we'll be glad actually to help you thinking along, or we'll be happy to think along with your new workflows and your new ways of approaching this. But yeah, it's by the way also just fun to do that. Again, I think I've been saying this before. The runtime is not just okay. I'm gonna nest something automatically, which is nice. I'm gonna run AMIS Pro automatically, but it's really about using the possibility to start dividing your parts over multiple batches simultaneously, and allowing that to, of course, take care of a higher density, more parts inside. More stable quality, and basically, and now I'm coming back to the start, let's say, basically writing different strategies for different parts, writing different approaches on how to nest specific parts depending on the part itself and the way it looks and the way it will behave in your build prep. And that's, I think, the real power behind the AMIS runtime. I'm looking forward to questions on this one, but also maybe tomorrow, of course, or through mail or whatever, or however you want to reach us. But so much for the runtime. Now let's look at a couple of upcoming features. And you've seen them already. You've seen me using it, of course, already partially because we're working on that. The next one, the version 304, is coming out already coming Monday. So that's the 30th of March, with an adjustable gizmo, which I also mentioned, new rotation shortcuts, so you can reset your rotation. We have a more stable SLI slicing, which was needed for one specific case. I hope they're in the room also. And then also for a specific customer, the question to make sure that the nesting ends when you press cancel. One thing I did maybe forget to mention. It's almost never needed to wait for the 100% when you nest. It's most of the time really okay to just see it go to 98%, have a look at it, click cancel, which basically means accepting the current solution, and keep on working from that or using that as a final build. We've improved the output and traceability and the CSV's JSON output, which really has a lot of data, which you can also reuse, of course, in AMIS Runtime. Also on the SLI export again. Behind the scenes, Adina is working hard on the portal, on basically more possibilities for support behind AMIS Pro, so that when you open and I don't know if I still have it open here, here you will soon see appearing more and more than just the license information, so to say. But that's coming one step at a time, which will also make it easier for us, by the way, to assign you a license for the AMIS runtime. Now, just after that, the version 3.5, which comes out on 3.5. No kidding, it's on May 3rd that we will have the version 3.5 coming out, which will have a couple of upgrades again. On the UX, on nesting control, on the direct HP connection, which we're really working very hard on, the Phasio integration, which will also benefit from the runtime, by the way, and some Boolean tools, as mentioned before, and the enhanced output for the part list. Of course, after that, there's still a lot of coming, and we're working very closely at the moment with HP on having their nesting rules translated into AMIS Pro, allowing you to, well, and then definitely also in AMIS Runtime, but also in AMIS Pro, to very quickly follow certain rules to come to optimized rotation, part placement, and nesting as soon as possible inside. So that's something we're also working on. The pricing is not a secret. It's also just on the website. These are the basic pricings. Of course, if you go for multi-year or multi-seats, we can discuss. We're always open for discussion. But this is the basic pricing. So now we do have, hooray, I did hurry up enough, or maybe enough, some time for your questions. And I hope there are a few. Adinda, do you have something for me? Did some questions come in? People, it's still time. You can still share them, eh?
Absolutely. Thanks so much, first of all, for the presentation. And indeed, please ask your questions. There were some questions about the screen sharing, but that's solved. So I'm currently not seeing any questions in the Q&A or in the webinar chat. So from Flores is, could you send me trial details tomorrow?
Yes, I can, but it's actually even easier, and it's still coming in the next section, by the way. You can just download a trial. If you just go to our website, click on download, I suppose. Anyway, you can very easily find the download section where you can just download AMIS Pro. We can transfer that to an AMIS Runtime if you want to, so that you always also have the AMIS Runtime access. For that, however, we still have to send you the AMIS Runtime package, the API, the information, the READMEs, the documentation, etc. So you can, by the way, if you just download it from the website, you got immediately a 7-day trial. We understand very much that in some cases you don't have the possibility to test everything in just 7 days. No worries, we can just extend that very easily. So just then contact us, give us your feedback, say like, hey, I need a couple of days more or a week more or whatever. We can definitely discuss that. So feel free. Okay. There is one small, by the way, that I did want to share while maybe somebody else is still typing a question. I don't know. But just by the way, probably later this week, we'll be able to announce that most of the MGF and SLS service providers in the Netherlands are now using AMIS Pro for their build preparation. That's just 1 year after we started selling AMIS. I think for us, it feels really nice, of course. On the other hand, these Dutchies, how do they do it, right? It's I think quite amazing. They're really trying to keep up with the latest developments. So we're very grateful to have so many Dutch customers. And of course, we're not stopping there. We're going to continue with the rest of the world. If there are no further questions, I don't know, Adina, did you still see something?
I don't see any questions now, but if there are, please do share them for as long as we still have the presentation going on. And if not, then please, we're always available by mail.
Indeed. Okay, then we can move on just to the recap, your key takeaways. But I think I hope at least that most was obvious. At least there were no questions. So maybe it was either too difficult or too easy. I don't know. It's really about strategy. How do you approach a certain batch? And I see it really. The guys that have been doing this for guys and girls that have been doing this for long enough, they see what parts they've got. They immediately know, like, okay, for this kind of parts set, I'm going to use that approach. Some other people use always the same approach, maybe because they have always the same parts, or maybe because they don't want to try something new. But please do try something new. It's really an opportunity to use all tools in the kitchen to create your own strategies that go faster, easier, better results, whatever you need at that moment. Runtime, of course, is a big thing. I really believe, and first of all, I was very glad to see that so many companies were already interested, and I really believe it's going to go on from there. It's not going to replace the IP or the people doing the build preparation. They will still be needed, but this can assist them and can free up space in your organization to focus on other things. As already mentioned, we're available for you as much as possible online for a meeting, or we can come by if needed. You can also soon see us in the US, in Boston at Rapid and plus TCT, where we're having a booth. So I do hope to welcome some of you there. We'll be in Germany, probably also visiting the Rapid Tech in Erfurt. And if needed, we'll gladly drive around to visit you as well, of course. And then we didn't decide yet. Your ideas are welcome to either visit Lyon or Birmingham at the TCT or the 3D print in Lyon. Um, since they're taking place at the same moment as every year, we haven't decided yet. So please help us deciding which one we should visit. There we won't be having a booth, by the way. We will just visit. But anyway, an opportunity, I hope, to meet you. And of course, saying that you're available anytime doesn't help if you don't share where you can find us. So this is where you can find us, and that's it for today. I would say thanks a lot, Adinda, for helping me out with this as usual. And of course, thank you very much for attending. We'll be looking forward to your questions. We'll be glad to help you out. And thanks for so many people to join us today. Have a nice evening and talk to you soon.
Thank you
Bye.
so much. Bye.